Okay guys, here's another example as to how we can use the rational exponents. They're asking us what is the fourth root of x cubed divided by the eighth root of x squared in simplest form. What they want us to do here is to actually reduce this expression as much as we can. How do we do that? We actually are going to use the rule again that the nth root of x to the m equals x to the m divided by x to the n. Again, remember the exponent goes in the numerator, so I'm going to turn this and rewrite it using rational exponents. So x is my base and it's going to stay the exact same way. My exponent from the inside is going to go on the numerator and the index is going to become the denominator. Notice how that's happening. I'm going to have my fraction bar that tells me I have a division. Again, I'm going to keep the x because that's the base here. The 2 is going to become my numerator, and the 8th, which is the index, becomes the denominator. Notice that if I divide both numbers by 2 here, and I divide it by 2 here, I actually get 1 over 4. So this reduces to x to the 1/4, right? So this actually becomes x to the 3/4 divided by x to the 1/4. So now you have to ask yourself, how can I reduce this further? And the interesting thing here is that we still have equal bases. So there is something we can do. We discussed, I think, last week that if we had equal bases, if I divided equal bases, remember if I had a to the third divided by a squared, I could go ahead and subtract the exponents because division of equal bases meant that I subtracted the exponents. So since that's the case here, I have x and x, which are my equal bases. I can go ahead and just subtract the exponents. So I have 3 over 4 minus 1 over 4. We have equal denominators, so we can just subtract the numerators. So this becomes x to the 2 over 4, and if we divide it by 2's, we have that our answer is x to the 1/2. So that would be our simplest form in this problem. So here's another example as to how we can use rational exponents. In this case, I want to work the other way. I want to turn this into a radical. So I'm going to keep my base. I first need the radical. Remember, the exponent is the it's the denominator. The index is the denominator, and the exponent is inside. Sorry if I confuse you. Let me say it one more time. The index comes from the denominator, and the exponent comes from the top. Okay? So here we have to ask ourselves something. How can I reduce this? And there is actually, this requires some thinking, but I want to kind of give you the technique you're going to use for the most part. We know that I can rewrite negative 32 as negative 2 to the 5th power. Why? Because if I have negative 2 times negative 2 times negative 2 times negative 2 times negative 2 5 times, I'm going to come up with negative 32. And in this case, I'm just going to go ahead and this exponent, I'm going to bring it out here because I'm allowed to do so. It's one of those things that just makes no difference in which order you do it. You can leave it for last, okay? So this is quite convenient because now I know that this exponent and this index are going to cancel each other out, and now all I'm going to have left is this negative 2 to the 4th power. What does that give me? Well, that just gives me positive 16. Here's another way to do the same problem. Let's say that I don't want to do this whole going back and forth thing. I can apply the same technique just here. This is my original problem, and all I'm going to do is do the same thing I did here. This is negative 2 to the 5th, and I'm going to have the 4 over 5 here. So this comes from our properties of exponents. I can just rewrite this, and notice that if you multiply 5 times 4 over 5, because that's what parentheses do, I put a 1 here, I have 20 over 5, which is just 4. So this expression becomes negative 2 to the 4th power, which is just 60. Here's the final example that I'll give you. What we want now is to simplify this expression and write it in the simplest form that we can. So at this point, if you do not remember the properties of exponents, go back and watch the videos because they're going to come out. They're going to come in handy. Specifically, please watch the power to the power. So go ahead and watch that one. Pause it and then come back to this video. Okay. So I'm going to assume that you went back and watched those. So essentially what you do in this case is realize, first of all, that both the 16, first of all, that the 16 is multiplying the y to the negative 8. And that this exponent is affecting everybody inside, both the y and the 16. Because of that, we can go ahead and rewrite it as follows. 16 to the negative 3 over 4 times y to the negative 8 raised to the negative 3 over 4. With that in mind, let's ask ourselves here, what happens if we simplify this? If you do the factor tree of 16, it's 4 times 4, which in turn becomes 2 times 2, which is 2 to the 4th. And over here, I'm going to do the math on the side. I have negative 8 times negative 3 over 4. Remember that I can put a 1 underneath. So I have negative times negative. So positive 24 divided by 4, which is just a 6. So with that, I can go ahead and say that I have y to the 6th. There's nothing else I can do here, so I'm done simplifying. But I got to go ahead and take a look at this. What can I do here? Well, let's repeat the process. What happens if I multiply 4 times negative 3 over 4? So again, I put a 1 underneath, and I'm going to have negative 12 over 4. Negative divided by a positive is a negative 3. So this then becomes 2 to the negative 3, and I'm going to separate my scratch work from my actual process. Again, remember that this negative exponent is going to send the 2 underneath. So I have a fraction bar. Negative exponents send you down there. Remember, we need to put a 1 on top times y to the 6th. The only thing left to simplify is 2 to the 3rd power is 8. And I have 1 over 8 times y to the 6th, or y to the 6th over 8. Okay guys, I hope this helps. We're going to have some practice tomorrow.